Okay, today's lesson is 4-2, Relations and Functions. I just took some screenshots from your textbook. So we're going to look at the definition of a relation, and we're just going to take it directly from the textbook. So I would like you to write down, we want you to write down the definition. So write down, if I can find my cursor, a relation is a set of ordered pair. Okay, so relation is a set of ordered pairs. So then it says here that if we look at the graph of the giraffe, that the 18 and the 4.0 is relation. So this age is our x and the height is our y. So they just went down here and listed the ordered pairs, x, y, x, y, x, y. Okay, and it says you can also represent a relation using a graph or mapping. So we can look at a relation and just look at it as a set of ordered pairs on a graph. So right in this area right here, looking at this. And then we can also do it by mapping. And mapping is right over here. Okay, so all those are relations. Okay, the domain. The domain of a relation is the set of first coordinates. So domain is another name for x. So on your paper or in your notes, put domain. Same is the same as x. So it's the same as the x coordinate. So it's just another name for x. And then the range of a relation is the set of second coordinates. So you're going to put range is another name for y. Or is the same as y. Okay, so when you hear the word domain, it's just your x values. If you hear the word range, it's just your y values. A relation that assigns to each value, in the domain exactly one x in the range is called a function. So I'm going to tell you the way I remember a function, and that's a lot of words. Okay, so on your paper, just write function and it's how I define it is for every x there is only one y. Okay, so this is a function. That's what that definition says. In more confusing words, I believe. So for every x, there is only one y. Okay, so here we got our definitions. Now let's go down and look at some examples. Okay, it says identify a function given a table. Find the domain and range of the relation is a relation of function. Okay, so for every x, there's only one y. That's how we determine if it's a function. But first of all, it says to find the domain. What is the domain? The domain, oh shoot, sorry about that. The domain is your x values. So if I look at this, here's my x values, here's my y values. So the domain is 100. So there's the 100, 200, 400, wherever it is at. 400, and 800. Okay, that's my domain right here is the 800 and the 400. Okay, my range, and I'm just putting them in descending order: 10, 20, 45, and 107. And that's my range, all my x values. Okay, so now for each value of the domain corresponds to exactly, okay, so does every x only have one y? And what you do is you look at 100. 100 is paired with 10. 800 is paired with 107. 400 is paired with 45. And 200 is paired with 20. Every x only has one y, so yes, it is a function. So it is a function right here. Alright, so now on your own, we'll pause the video, and I want you to determine, find your domain and find your range, and then determine if it is a function. Okay, so now that you had a chance to try it on your own, I put our answers up here. So I found the domain. Domain is your x values. So I listed my x values, which is right here. Domain is -4, -2, 3, and 5 for the first 1a. And my range was -1, 0, and 3. Okay, and it says it is a function because for every x has a different y. So -2 has 3, 3 has -1, 5 has 0, and -4 has 3. Okay, so 1b, the domain is -3, 6, and 8. Just write -3 once because there's 2 of them. The range is -5, -2, 4, and 7. And this is not a function because -3 is paired up with -5 and +4. So therefore it's not a function, because remember, for every x there has to be only one y. And that x, -3, has 2 different y's it's paired up with. Okay, and another way you can find out if it's a relation or a function is to do a mapping diagram. So you're going to find the domain and the range of each relation and use a mapping diagram to determine if it's a function. So they took our order pairs right here and they listed them vertically. So we have 11, 12, 13, and 20. And then our range, or our y values, are -2, -1, don't list -2 a second time, and 7. So they listed them, and then they mapped them. So they just said, okay, 11 went with 2, 12 went with -1, 13 went with -2, and 20 went with 7. Okay, now the only important thing is every x valued with just one y. Doesn't matter, y can have as many partners as it wants, but we have to worry about x. X can only have one value. And does it? And it does, so yes, it is a function. Okay, let's look at the next one. So we took our order pairs here, and we are going to list them, the domain and the range, so our x values and our y values, and we're going to list them, so -2, -1, and 6. Don't list -2 twice, and then -1, 0, 1, and 3. Okay, so now we're going to pair them. -2 went with -2 went with 1, -1, -1 went with 0, 6 went with 3, and then -2 also went with a +1. So therefore this is not a function because that x value, -2, has two y values. It has a -1 and a +1. Okay, and then another way you can tell whether a relation is a function is to analyze the graph of the relation using the vertical line test, and that's what we're going to do now. If any vertical line passes through more than one point of the graph, then for some values of x, there is more than one value of y. Therefore, the relation is not a function. All right, what's that mean? Okay, we're going to find the domain and range of each relation, use the vertical line test to determine whether each relation is a function. Okay, so now on the first graph here, we're going to go through and just list the ordered pairs. So we have +3 and 2. That's this one, +3 and 2. And then we have +3 and 0. So we're going to go through and we're just going to list each of them. And then we have 0, -1, and that's this one. And then we have -2 and 1. And we have -3 and 2. Okay, so we listed our order pairs. Now we determine the domain and range. The domain is all your x values. So your x values are 3, 0, -2, and -3. And then you're going to determine your y values, which are -1, 0, 1, and 2. All right, so now you can take your pencil, like the picture shows here, and you can put your line, your pencil, and create a line right here. Now, do these two, the value of 3x, so x that's at the 3, how many values of y does this have? It has 2, right? So therefore, it's not a function, because when you put your pencil straight up and down, if there's more than one dot on that line, it's not a function. So over here there's just one, so that's okay. This one there's just one, that's okay. This one's just one, that's okay. But when you got over here, it's not a function because there's 2 points on that x value. Okay, so we're going to do the same thing here. We're going to use our vertical line test to see if it's a function or not. So it says, if I take this and I put my pencil, and I just do that everywhere on here, is there anywhere on this line that has more than one point? And it doesn't. So this one is a function, because no vertical line intersects the graph at more than one point. Okay, if I did this one, here's my pencil test. It's not a pencil, it's a yellow line. But how many points are on each of those x values? 2, right? And same thing, so they actually, this is not a function. Okay, so that's what we're going to do today. You've got a worksheet to do, and hopefully that makes sense.